Class, my name is Professor Brian. Welcome to Material and Energy Balances. Since this is your first chemical engineering class, I want to make sure you know what a chemical engineer does. Does anyone have any ideas?
Engineering chemicals?
My mom told me that they make paper.
Not really. That's only one of the things they do.
Make processes more efficient?
That's part of their job, but there is more to it than that. Chemical engineers conceive and design processes to produce, transform, and transport materials, beginning with experimentation in the laboratory and followed by implementation of the technology in full-scale production. They're involved in the fuel, plastics, medicine, food, and packaging industries.
Oh.
Now that I think about it, chemical engineers are even responsible for purifying that water you're drinking.
Really? How does that happen?
I'll show you! The first step in the water treatment process is intaking water from sources such as lakes and rivers. This unclean water contains many microorganisms and other impurities, like dirt, that make it hazardous to drink. Engineers add a chemical such as aluminum sulfate to make smaller particles clump together to form larger particles. This is called coagulation, which is useful because larger particles are easier to remove from the solution in the filter stage. This is an important step in the process because solid particles smaller than the pores of a filter cannot be stopped. These larger particles are then driven through a filter comprised of sand and charcoal. The water travels through the sand first, removing the larger particles and small bugs. Dangerous bacteria such as E. coli are also removed. That being said, it doesn't filter everything. Most viruses and dissolved metals are too small to be affected by the sand, and sand may be less effective at lower temperatures. After the water filters through the sand, it begins to move through the charcoal layer. According to the EPA, while the charcoal filters out organic contaminants, pesticides, and herbicides, it does not filter out dissolved solids, coliform, bacteria, and inorganic contaminants. The activated carbon in charcoal acts as an adsorptive filter. It can also effectively remove organics and chlorine, and has a long lifespan. The water is now free of most particulates, but still contains microorganisms, so it's still unsafe to drink. There are three main techniques used to kill microorganisms: ultraviolet light, ozone, and chlorine. However, ultraviolet light is the most commonly used technique in small-scale water treatment plants, so this is what we'll talk about. UV light works by damaging RNA and DNA in microorganisms. The advantage to this is that it doesn't leave behind harmful chemicals. However, it only works on water if all particulates have already been removed because they absorb light. The water is now clean and ready to drink.
Delicious.
But Professor, why do we even need water treatment? Isn't most of the Earth covered in water?
You're right! According to National Geographic, 71% of the Earth is covered in water, but less than 0.007% of the Earth's water is drinkable. The rest of it is salt water or fresh water that's trapped in ice. Now we'll start talking about basic mass balances.